will see our code, vulnerable code. So as you can see in this code, let me explain a little bit about this code. So in this code what I am doing is that this is here I am declaring a structure. It contains a character array of size 64 bytes. Next I am declaring a structure and it contains only a function pointer, and then next is a function. Here I am calling a shell. This function is calling a shell, and there is access denied function which is printing a message. So what I am doing here is that here I am allocating a structure like as I told you, the structure contains the array of an array of 64 bytes. So and then I am declaring two pointers using this structure, two function pointers, and we can ignore this one. Okay. So next what I am doing is that I am here I am calling malloc to allocate memory to this structure, this pointer, structure pointer, and then I am calling malloc to allocate the memory to the function pointers, these two function pointers. Then I am using this memory allocated to this function point like f going to fp. I am giving them pointer address to this function, these two functions. I am giving their start addresses to these pointers. Now I am using, as you can see, that strcpy. I have used strcpy to take an argument, copy an argument from command line into the name variable of this structure, of this D structure D. So as you can see that strcpy is our vulnerability. If we pass an argument greater than 64 byte, then it will overflow the heap and write its neighboring memory. So what I am doing that whatever the user is giving, I am storing it into this name array, and then I am comparing with hello. If user enters actually hello, then access granted function is called using this function pointer, and user will get a cell. If user enters anything other than hello, then this access denied function will be called, and it will print wrong password. So let's first run this code. Let's see, dot slash hello. So we are getting a cell. Okay, now let's pass something different like hell. Yes, so our code is working properly. So in this to exploit the vulnerability in this code, what we will do is, so let's open GDB first. We will do like GDB. Now we'll put a breakpoint to at line 36. Now we'll run into something garbage values like. So let's see the process memory space with the command info proc map. So as you can see, there is in the process memory space, address space, there is no heap. As you can see, there is stack is here, but there is no heap in the process memory space because no malloc function has been called yet. So let's do the next malloc function is called. Now let's see the process memory space. So as you can see, the heap memory has been allocated and the size is 21,000, that is in a hexadecimal. If you convert it into decimal, and then you will see that the size is of 132 kilobytes. So now let's next. Now we know that address of our heap starts from 602000. So let's see the contents of heap. We have allocated memory on heap, and we have also allocated functions on heap, and the strcpy function we have not executed it yet. So let's see the heap memory at this point. So I will call like x32x, and the heap memory was at 0x. So as you can see, this is the start of our heap. So since this is a 64-bit system, the first 16 bytes have been used for metadata. Let's see the addresses of these variables like d. So you can see this is the start of the memory for the d structure. Let's see about f. A. This is the start of the A, and about F. This is the start of the F. So as you can see, we have as you can see, our 602060 contains an address like 400646. So what we can see from here, that we have allocated this function stored this function pointer, access granted function pointer, to this A address. So let's see the address of our function pointer function access granted. The start address of this function should be 046. So let's see. So as you can see, this is the start address of our function access granted. And as you can see, the start address of our it means is it like x/40x 0x602000. So as you can see that the start address of our F memory allocation is 602080, and in this we have stored the function pointer of our function access denied. So let's see the function pointer of our function access denied, like p/x, no, not p/x, disassemble access denied. So as you can see that it contains the address of the function pointer. So now what we will do is, when we fill this name buffer with a command line argument, it will start filling from here. So it will start filling from here, and if we override this and we modify this function pointer access denied with the address of, override this function pointer address with the address of this access granted function pointer, then even if we enter a wrong other than hello message, even if the argument is other than hello, then still we will get a cell. So then our attack will be successful. So I have created a payload for this purpose. So what we need to do is, it's starting from here. This we can count like starting from here. We have to override this much with the this much memory locations with A's. So this memory locations are like 16. This is like 16 into 7. 16 into 7 means it is 16 into 7. This is 4 bytes memory locations we have to overwrite with A's. With overwrite is like 16 into 7 is 12 memory locations we have to overwrite with A's. Then we will overwrite this 400657 with the address of function a function pointer. So we will do it like yeah, it is already correct. So this is the payload for our attack. So let's execute it, and as expected we got a message wrong password. So now we will execute our code with the payload T64 dollar Python payload.py. So what will happen is actually let's do it with ZDB. We will get a clear point of view. So ZDB./T64. Now let's run our code with our payload. So let's see the stack at this point, heap at this point of time. So our heap, we know that it is 0x60 20 0. So this is our heap. As you can see, the function pointers of a and fr. A is stored here and fr is stored here. Now execute our strcpy function. What we'll do with all of these locations will be filled. All of these locations will be filled with A's, and this 400657 will be replaced by 400646. So let's go on to our next instruction, and let's again see the heap. So as expected, and the function pointer is changed to the access granted. So let's continue our execution, and now we'll likely get a cell. So let's execute it, and as expected we have got a cell. So our exploit is successful.